Assalamualaikum, my name is Muhammad Azmi Hizran bin Ahmad Kamil. Today I want to present about introduction. This case study examines the intricate issue of vehicle speed along Jalan Keluang, focus on the overpass in front Palapis UTHM Parit Aja Johor. By analysing traffic data collect at specific intervals, the study highlights the connection between overall speed vehicle. The data includes speed measurement record every 30 meters from overpass between 3:30 p.m. to 5:30 p.m. in one day at Wednesday after class. Problem statement. Executive vehicle speed is a significant contributor to traffic accident, injuries and fatalities worldwide, making it critical area of the research in traffic management and road safety. Despite of implementation of speed limit and traffic enforcement measures, non-compliance with speed regulation remain prevalent, raising concern about the effectiveness of current policy. Moreover, limited data on specific pattern impact the vehicle speed under varying conditions such as road types, weather, time of day, and the development of target interventions. This problem is further exacerbated by the growing need to address environmental concerns as higher vehicle speed often result in increased fuel consumption and emission. Objective of research about statistic on vehicle speed typically involve understanding pattern behavior and impact related to vehicle speed. Specifically, objectives may include: Point 1. Analyzing speed pattern to identify trends in vehicle speed under various conditions. Second, safety assessment to examine the relationship between vehicle speed and road safety. And third, impact of environment to study how vehicle speed affect fuel consumption and emission and overall environmental impact. And lastly, behavior insight to understand driver behavior related to speeding, such as common reason for exceeding speed limit or the influence of distraction.
Assalamualaikum warahmatullahi wabarakatuh. My name is Awam, and for the methodology, first one is study area and data collection time. The data was collected on Federal Road 50 in Johor, Malaysia, which connects Batu Pahat and Jamal Luang. The data collection took place on Wednesday afternoon from 3:30 p.m. to 5:30 p.m. during peak traffic hours. Next is data collection method. We observed 4 vehicle classes: motorcycle class 1, cars and small vans class 2, truck and vans class 3, and heavy load trucks class 4. Data was recorded from an overpass where vehicle were tracked as they passed 30 meters beyond the point. Next one is technology used. We use SpeedGun app to accurately measure vehicle speeds and distance. The app allows us to start timing when a vehicle passed under the overpass and stop when it had traveled 30 meters. And lastly is data analysis. We analyze the data using the descriptive statistic, creating frequency distribution tables and box plot to visualize speed trends. Two sample hypothesis testing was used to compare the speed of cars and trucks, while ANOVA tested differences in speeds across all vehicle classes.
Next, we go to the literature review. Bicycle speed significantly impact traffic safety, efficiency, and environmental sustainability, as evident by various studies. Speeding increase crash severity and risk, with crash rate rising exponentially with higher speed and narrower or more complex roadway. Moreover, reduced speed limit such as lowering from 90 km per hour to 70 km per hour have been shown to decrease serious crash rate by 30%. Intelligent Speed Adaptation (ISA) technology features enhanced safety by reducing speed variability and man speed, thus mitigating accident risk. The relationship between speed and safety is also influenced by contextual factors such as road geometry and traffic density, underscoring the need for tailored speed management policy. Effective speed regulation supported by advanced technology and data-driven model offer a critical pathway to achieve safer and more efficient transport system.
My name is Muhammad Hazim bin Rudin. I will present this presentation data in raw data. So this table shows the raw speed data we collected for 4 types of vehicles on Jalan Keluang. The vehicles types are: class 1 is motorcycle, class 2 cars and small vans, class 3 trucks and standard vans, and last class 4 is heavy load trucks. So we collected total of 118 speed observation. The numbers in each now represent the speed in kilometers per hour for each vehicle type. For example, motorcycle in class 1 has speeds ranging from 41 to 79 km per hour. Next, cars and small vans in class 2 recorded speed between 57 and 83 km per hour. For trucks and vans in class 3 range from 41 to 87 km per hour. And last, heavy load trucks in class 4 range from 43 to 82 km per hour. So the data was used to analyze vehicle speed patterns and compare difference between these groups, which I explain further in the next part of the presentation.
Assalamualaikum, my name is Amir Izuddin. Bin Zulkifli, my matrix number is DF230110, and I will present about the descriptive statistical analysis for class 1. Okay, so let's start with the table on the top left. It shows the speed interval, frequency of vehicle in each interval, point calculation, and cumulative frequency. The frequency distribution histogram below visualize the data, giving us an idea of how vehicle speeds are distributed. So the peak of the data is around 65 to 70 km per hour range, indicating a higher frequency in this category. Next, the cumulative distribution curve. The cumulative distribution curve provides a cumulative view of frequency, helping us understand how value accumulate across interval. It shows at 79 km per hour represent the maximum recorded speed of vehicle. For the box and whisker plot, the box summarizes the minimum, maximum, median, and quartiles. It shows the interference for detecting potential outliers, giving us a comprehensive view of data spread and variability. So this is the calculation for the statistical measure, which is the mean is calculated is 63 km per hour, the median is 66.38 km per hour, the mode is 73 km per hour, and then for the variance is 103.57, and standard deviation is the square root of variance, which is 10.18, and then the first quartile, which is calculated, is 54.81 km per hour. For the third quartile is 74.32 km per hour. The upper inner fence calculated is 103.59 km per hour, and the lower inner fence is 25.55 km per hour. So this data is used to make a box and whisker plot, and then the another graph and another histogram and graph. Next is for class 2. From the table and the frequency distribution curve, we know that the highest frequency is between 61 and 65 range, and from the cumulative distribution curve, we know that 88 is the highest speed of the vehicle. And then for the box and whisker plot, we can know that the lower inner fence, and then the upper inner fence, first quartile, third quartile, minimum and maximum. Okay, this is a measure for statistical analysis class 2. The mean is 62.74 km per hour, the median is 66.25 km per hour, mode is 68.83 km per hour, and the variance is 128.57, and the standard deviation, which is the square root of 128.57, is 11.32. And then the first quartile is 54 km per hour, the third quartile is 70.08 km per hour, the upper inner fence is 94.2 km per hour, and lower inner fence is 29.88 km per hour. Data for class 3, we can know that from the table we can know that the highest frequency is in the range between 56 to 60, which has 8 number of frequency. And then same goes to the frequency distribution curve, which is show that 56 to 60 has the highest frequency. And from the cumulative distribution curve, we can know that the highest vehicle speed is 88. And then from the box and whisker plot, we can know that the lower inner fence, upper inner fence, first quartile, third quartile, and minimum also maximum. With the data for class 3, the mean is 59.15 km per hour, the median is 58.63 km per hour, the mode is 57.72 km per hour, and variance 122.35, and the standard deviation is 11.08, which is the square root of 122.35, which is variance. The first quartile is 53.63 km per hour, the third quartile is 66.75 km per hour, and lastly is upper inner fence 86.43 km per hour, and lower inner fence 33.95 km per hour. This is for class 4, which is from the table and frequency distribution curve. We can know that the highest frequency show at 56 to 60 range of speed of vehicle, and then the cumulative distribution curve show that the highest speed is 88, and then the box and whisker plot show that the median is 57.58 km per hour, the first quartile is 51.75 km per hour, third quartile is 65.08 km per hour, and the upper inner fence 35.08, lower inner fence is 33.76, and the maximum is 87 and the minimum is 43. From this statistical measure, the mean show that the value is 57.31 and the median is 57.58, the mode is 56.75, the variance is 134.83 and the standard deviation is 11.61. The first quartile show that the value is 51.75 km per hour. The third quartile show that 65.08 km per hour. And lastly, upper inner fence 85.08 km per hour and lower inner fence is 31.76 km per hour.
Next slide, two sample hypothesis testing. We conduct a hypothesis test to compare the mean speed of light vehicle, mean X, and heavy vehicles, mean Y, measured in km per hour. The sample size were Nx equal to 97 and Ny is 51, with respective means and standard deviation shown in table 5. The hypotheses were as follows. H9 is mean X less than or equal mean Y. For HA, mean X greater than mean Y. So as a significant level of alpha is 0.05. We employ a one-time Z test because the sample size exceeded 30, allowing us to assume normal distribution for the sample means. The critical Z value for alpha is 0.05 was determined as Z critical is 1.65. For the calculated Z value was computed using the formula in the below. So then substitute the values and we got Z calculated is 2.396. Next, the Z distribution curve illustrates the Z calculation is 2.296 falls in the rejection region, which means Z calculated greater than Z critical. Thus, we reject H0 and accept HA. So conclusion is the mean speed of light vehicle is significantly greater than the mean speed of heavy vehicles. That's for me. Thank you.
Okay, for the next slide, I will present about analysis of variant, which is called ANOVA. We assume that HO is the mean speed of vehicle are all equal, and the HA is the mean of speed of vehicle are not all equal, which is at least two means are different from each other. Okay, for the degree of freedom, which is numerator, also called V1, is equal to 4 minus 1 is equal to 3, and the degree of freedom for denominator, which is V2, is 118 minus 4, which is 114. For the F critical, we calculate, we get 3.952, which is the significance number is 0.01. The distribution show that the position of F critical. We calculate the value of F critical by using F distribution table and using interpolation. From this table of analysis of variance, we calculate the SS, which is 14,401.36, and the SST is 303.36, and then the SSE, which is SS minus SST, which is we get 14,098, and we get the F value, which is 0.818. After the calculation of critical and F, we compare the data, and then based on the ANOVA result, we now hypothesis that the mean speed of vehicle across all classes are equal to accepted. As the calculated F value, which is 0.818, is less than the F critical, which is 3.952, indicating no statistically significant difference between the two means.
Next slide, discussion. In this session, we talk about our study on vehicle speed. Along with the network, we analyze the four types of vehicles such as trucks and small vans, trucks and vans, and heavy load trucks. In this statistic, we have the statistic and ANOVA. So we found that motor vehicles had the highest average speed, followed by trucks and small vans. Trucks and heavy load vehicles was lower. The same has confirmed that light vehicles had motorcycles and cars travel significantly faster than heavy vehicles. However, the ANOVA results show no significant speed difference between individual vehicles classes. This suggests that road conditions or speed limits may lead to similar speed across the road. So this result highlights the need for target traffic management to ensure safety, especially for light vehicles in mixed traffic. Future study could look at factors like road conditions, weather, and time of day for deeper insights.
Lastly, the conclusion is This study highlights key factors influencing bicycle speed, which affect road safety, traffic efficiency, and environmental sustainability. Findings show significant variation in speed based on bicycle type and time of day. With higher speed during morning peak rising safety concern, automobile had the highest speed while heavy truck, bus were the lowest. Using methods like ANOVA, the study emphasized the need for tailored traffic regulation considering road type, time, and bicycle classification. Recommendations include time-based law, bicycle specific speed limit, and adaptive monitoring. It addresses knowledge gap and suggests future research on factors like traffic volume and weather to enhance safety, efficiency, and sustainability. That's all from me. Thank you.